So when we learn geometry, one of the things we want to acknowledge is that the geometry we're actually learning is called Euclidean geometry. It is the geometry with which we are most familiar that deals with flat space, stuff on the coordinate plane. And here the rules are all very familiar. The angles of a triangle add up to 180 degrees, lines go on forever, etc. But there are other types of geometry, most notably spherical and hyperbolic geometry. These are called non-Euclidean geometries. And the rules of the game are different in these two spaces. On a sphere, the angles of a triangle can now add up to more than 180 degrees. And in hyperbolic space, or sometimes called saddle space, the angles can never add up to 180 degrees. And just to give you a quick connection to the real world and why that might matter. Here is a picture of the Earth. And you can see in this box here, they have zoomed in very, very close onto one little section of Japan. And at that scale, things are basically flat. And so we use Euclidean geometry to describe angle measures and distances and lines and these things, because it's basically flat. But if you zoom out far enough, the Earth is a sphere, or approximately a sphere. It's a globe. It's no longer a Euclidean space. And so here we can have a triangle on the face of the Earth, because the Earth is a sphere with angle measures with 2 right angles down there at the bottom. And in fact, I think you could have 3 right angles inside of one triangle if you just made it large enough and cut out a 90-degree wedge or triangle. You could have a 270-degree triangle. So the short version here is that the rules of the game are different in a spherical space or a hyperbolic space. We won't do much with those other than acknowledge their existence.